So the other day in class we would have started to talk about types of problems that we could execute using circular trig. Remember that the word that we had introduced was circular trig. And circular trig had to do with the way that we put right triangles into the unit circle. It introduces the way that the plus or minus, which occurs when we look at angles above 90 degrees. We wanted to have an explanation for why when I punched in, sine of 332 into the calculator, I got out something that was negative. And that's going to help us be able to do the next step in the process, which is solve. So the types of example problems we're going to work on look a little bit like this. And so let's take a look at the example problem. Find the value of all 6 trig functions for the angle x if sine x equals minus 3 over 5, and the angle itself is between 180 degrees and 270 degrees. So let's start at the end with 180 to 270 degrees. That tells us where we expect to find the angle. Right? Now, 180 degrees around our unit circle and 270 degrees marks off our angle as being in the third quadrant. So we'll just for a second imagine some arbitrary angle in the third quadrant. And say, oh, we rotate all the way around to this, right? That's the angle x. And we remember from class the other day that the way I handle and deal with that angle x is not by looking for a triangle that it fits the entire angle, but by looking for a triangle that fits in that particular quadrant. I drop a line to the x-axis to create this right triangle. So now, right, this angle right here, right, which we don't really name necessarily, but it's an angle in a triangle, has a sign, right, so we can call it a question mark. We're not sure how big it is, but we know that it has a sign of minus 3 over 5. Okay, so sine is opposite over adjacent. So that means that this side is minus 3 and this side is 5. Now I want to find the value for all 6 trig functions. Right? So in order to do that, I need all 3 sides of the triangle. So the first thing I'll do is I'll use the Pythagorean theorem to find the third side. Although if we remember our triples, we should know what the third side is already. In this case, it's negative 3 squared plus b squared equals 5 squared. So b squared equals 16 and b equals 4. Now I would put 4 here, but remember that plus or minus, when we draw that on the triangle, is based upon whether or not the particular coordinate is plus or minus. I mean, this side is negative 3. This side is negative 3 because we're going down 3 units. This particular side of the triangle is negative 4 because we're going left 4 units. Now from that point forward, I have a triangle with all 3 sides, and the negatives are designed to tell us that the sine or the cosine or the tangent values would be negative in that particular quadrant. Right. So what do we do? Well, I want to say, okay, well, sine x in this case I already know is negative 3 over 5. But cosine x now is going to be negative 4 over 5 because the adjacent side over the hypotenuse. And tangent x is going to be opposite over adjacent. So it's actually going to be 3 over 4 because I'm dividing negative by a negative. Now let's do the other ones. Right? Cosecant x is 1 over sine x, so that's negative 5/3. Secant x is 1 over cosine x, so that's negative 5/4. And cotangent x is 1 over tangent x, so that's 4/3. And that's all there is to it, all 6 values of the angle x. Okay, those are the unique values that attach to the angle. Let's take a look at a second example. Find the value of all 6 trig functions for the angle x if sine x equals minus root 3 over 2 and the angle is between 270 and 360 degrees. This last part, again, let's start at the end. This last part tells us that x is in the 4th quadrant. So we'll imagine some angle down here in the 4th quadrant. It might look something like this. That first drawing is just a guess. But the information I do have is that this particular side of the triangle is minus root 3, and that hypotenuse is 2, if this is our reference triangle. And remember that the angle, we can just ignore that for a second. Let's get rid of that, it doesn't belong in there. Remember that the angle is all the way around, it's come all the way around this way. But the triangle that we use to talk about the side ratios is the one that we drop down. Right, so the right triangle that's built in. The third side here is going to be 1. We know that because this is our 2 minus root 3 is 1, 2, root 3. This is actually a 30, 60, 90 triangle. All right. If I needed to, I could again go back to the Pythagorean theorem to find that third side. And we'd find out that it was 1. Okay. So again, we're ready to do all 6 trig functions. We say, sine x equals minus root 3 over 2. Cosine x, in this case, equals 1 over 2. Now, we didn't talk about that side 1. Right? I just kind of put it there. I didn't state that it's positive or y. But if we look at this, right, remember that we're on the positive side of the x-axis now. We should understand why that's a positive 1. When it comes time to do tangent of x, it's negative root 3 over 1. When I want to do cosecant x, it's negative 2 over root 3, or negative 2 root 3 over 3. When I want to do secant x, I flip it, and I get 2. And when I want to do cotangent x, I flip tangent, and I get 1 over root 3, negative 1 over root 3, and that rationalizes to negative root 3 over 3. And again, here are all 6 trig functions. Right, the value for all 6. What we needed to do is we needed to first find and place the triangle, and then we needed to find all 3 sides, and then finally we needed to place the definitions. Since I needed to place the right sides and the definitions for all 6. That should be enough information to do the homework problems tonight. It's not super complicated. Obviously, we'll go over them tomorrow and make sure that we're all caught up.